Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
We are making those lines glow in the dark so that they are more detectable, so the sensitivity of the test is better, said Richard Willson, Huffington-Woestemeyer Professor of Chemical and Biomolecular Engineering and Professor of Biochemical and Biophysical Sciences, who previously created a CO. The first idea for glow-in-the-dark technology sprang from a star pasted on the ceiling of Wilson's young daughter's bedroom. One night while he was putting her to sleep, he peered at the glow-in-the-dark star and his mind began to wander, applying its principles to science. Within days, Wilson and his team of students and postdocs was creating a test with glowing nanoparticles made of phosphors, which would make the particles even more detectable and the tests more accurate. Two of the students became the founders of Luminostics, now called Clip Health, a spin-off from the Wilson Lab. Now in the Wilson Lab, the next generation is developing. In this new development, there are two tricks. First, we use enzymes, proteins that catalyze reactions, to drive reactions that emit light, like a firefly. Second, we attach those light-emitting enzymes onto harmless virus particles, along with antibodies that bind to COVID proteins, reports Wilson in the Royal Society of Chemistry's journal Analyst. The reason these steps are useful is that one antibody on a virus can bind to one COVID target on the test strip and bring along with it many light-emitting enzymes. So, the team gets more light for each target, thus needing fewer targets to see the light, making the test more sensitive. And while you might be able to read the results with your eye in a very dark room, the Wilson team created a little plastic box to exclude light and let a smartphone camera do the reading. This is more reproducible and probably more sensitive, and with smartphones you can communicate the results to databases and things like that, said the paper's corresponding author Katerina Karenzi, University of Houston Research Associate Professor of Chemical and Biomolecular Engineering. Jacinta Conrad, Frank M. Tiller Associate Professor of Chemical and Biomolecular Engineering, also from the William A. Brookshire Department of Chemical and Biomolecular Engineering at the University of Houston Cullen College of Engineering, is on team. Others from UH include the first author of the paper Mead Chaubey, Bin Vu, Kristen Brosemer, Maxwell Smith, and Dimple Siobhan. Wilson adds the sensitivity is really excellent, better than essentially any commercial tests, making the technology useful in an array of medical arenas. This technology can be used for detecting all kinds of other things, including flu and HIV, but also Ebola and biodefense agents, and maybe toxins and environmental contaminants and pesticides in food, said Wilson. So truly, the sky and stars are the limit. Thanks for watching. Please subscribe my channel for more videos.